Hi, everyone. Thanks for joining. We're excited about today's webinar topic. We'll be reviewing the Groovy roadmap with Paul King. Paul is the Groovy lead here at OCI, and he has a lot to share with us today. So I won't take up too much time with intros, just one little housekeeping item. If you have questions during today's talk, just please type those in the chat box. We're moderating that chat box and we'll answer the questions that we can answer there in a written form. And then at the end, we'll have a Q&A where the questions will be read out loud. And also, there's already a question coming in, and that is, will the session be recorded? And the answer to that question is yes, it's being recorded, and it will be distributed to everybody who signed up for the course today. So with that, I'll hand it over to Paul.
Thank you, Nikki. Okay, my name's Paul King, as I've been introduced. I'm the Groovy lead at OCI. And today we're going to talk about the Groovy 2.5 roadmap, which it's a very exciting time to be talking about that because we're on the cusp of releasing Groovy 2.5. The RC3 release will probably go out later today, or it'll go to a voting stage later today. And if that's successful, it'll be released first thing next week. And then within a week after that, we're hoping, pending feedback, if everything's going well, we're hoping to do the final release. So that's good news. So OCI are much bigger than just Groovy and Grails. You're probably aware of them from that side of things, but they're actually got over 160 engineers, and there's many things that they're interested in. So make sure you look them up. If there's anything in the software engineering area that you need, if there's any training needs you have, make sure to find out more about them. They're the home of Grails, and if you haven't heard about it before, there's going to be a lot more news coming your way about a microservices framework called Micronaut. So to be officially announced, officially launched as an open source project very, very soon. You've probably seen some pre-release info, but stand by for a whole lot more exciting information on that. Okay, so Groovy is still been growing tremendously, even though there's other languages like Kotlin and so on these days on the JVM that have been getting a lot of press. The Groovy download numbers still make it the second most popular language on the JVM after Java. And the numbers just keep increasing. For the first quarter of this year, I think there was 19 million downloads, which is twice the number of downloads as the first quarter of last year. So you can see it's still a lot of interest in Groovy, still a lot of usage, and the releases this year. And as I said, a couple more releases coming very soon. On the 2.5 front, which is the RC2 is out now. RC3 later today. I'm hoping to set the voting in process for that release. The GA we've targeted for the first half of 2018, and it looks like we're going to just scrape ourselves in and sneak it in just about the same, just by the end of this month. So that should be good, or early next month. What's in 2.5? The big ticket items, there's a whole lot of improvements in AST transforms. There's a brand new feature called macros, and there's various miscellaneous features that I'll briefly go through. It's we've bumped the minimum JDK version up to JDK 7. Hopefully most people are at least on 8 these days. It runs on 9 and 10, but with certain warnings. Everything runs fine. No behavior is impacted at all by those warnings. They're just indicating that sometime down the track, whether it be JDK 11 or 17 or something like that, there's going to be some features that we're relying on that will no longer be there. So we'll definitely have replacements to those features by the time that comes along. So you can sort of ignore those warnings. They're just a little bit annoying in the meantime, and we'll be doing what we can to get rid of them as early as we can. The other exciting news is that 2.6 and 3 are around the corner. I'll explain what those version numbers mean. The alphas are out now. There's a lot of really interesting work in that with a brand new Parrot parser. JDK 8 is the minimum for Groovy 3 and beyond, and a whole lot more work is going on in the JDK 9 plus space. So I'll talk a bit more about that a bit later in the talk. So first off, let's now look at 2.5 and run through those improvements. So you can see that's the list of AST transforms that are in Groovy. You can see there's about 50 odd in 2.4. Many of those have got improvements. I'll talk about that next. But you can see there's more than 10 been added in 2.5, and so far just one added in Groovy 3, but possibly more to come down the track. Just looking at one of the pre-existing AST transforms, this is the tuple constructor. These are the annotation attributes. So these are how, when you're using tuple constructor, you can configure it. You can tell it whether to include fields as well as properties and things like that inside the parameters that are specified in the constructor for you. You can see there that there's additional 7 annotation attributes added. So even in the 50 odd that were on the previous slide that were pre-existing, many of those have got new improvements to them. A lot of those improvements are to improve the consistency across all of the AST transforms. So some of them had a all properties annotation attribute and others didn't, and so on. Now it's a lot more consistent across the board. If the tuple constructor has an all properties annotation attribute, you'll probably find that the map constructor, which I'll talk about later, also has a very similar thing. So and the other good news is the implementation of a lot of those is the same. So you should definitely get identical behavior when you're using those different features. What else happened? We reworked 2 of the probably most commonly used annotations, canonical and immutable. They're now meta annotations, or also known as annotation collectors. And what does that mean? There's now an ability, well, there has been an ability for a while to collect annotations. And if you've got a bunch of annotations that you're interested in, you can collect them all together and use them under a different annotation. So you can actually define your own. You can use this feature yourself. And I'll talk a bit more about that in a slide or two's time. So in fact, whenever you use canonical now as an annotation, very early in the compilation process, it just gets replaced with the other 3 annotations. And you might wonder, what did we have to do to make that happen? Well, apart from creating the annotation collector capability, we simply had this definition of canonical. So you can see the add interface canonical down on the last line. That's the normal way you do an annotation definition. We just add a special annotation to that just says this is an annotation collector, and it just collects the other 3 annotations. Okay, there's a little bit more detail there about a way you can merge things. I'll explain that on the next slide or 2. But that's, if you go and look at the source code, that's the full definition of the canonical annotation. And so you can do that yourself. Okay, what does it mean? It means early in the annotation process, that canonical just gets replaced with the other 3. And you can see there's an include names annotation attribute. That'll get spread across whichever of the collected annotations support that attribute. So for include names, only toString has that annotation attribute, so it's the only one that'll get spread to. If you happen to have something like excludes, when you spread that, it'll go to all 3 because all of those 3 now support excludes. Okay, let's have a look at the same how all that works for immutable. In fact, immutable has now been split up into a bunch of more fine-grained annotations that you can now mix and match yourself. So when you use immutable, instead of just being the 3 that canonical had, you get the toString, you get the equals and hash code, you get the tuple constructor, but you also get a bunch of other things. You'll get a map constructor, you'll get things like immutable options, property options, and so on and so forth. You've got the ability to mix and match any of those yourself if you don't like any of the settings that we've now given you. So immutable used to be a great feature to have, but often people would say, I really like it, but I don't like this particular part of it. And because I need that different, I can't use immutable and I'll have to go and do everything by hand. Well, now you can go and tweak things if you want. And if what you can do is actually just copy that code exactly as you want. On the very last line, change, instead of having immutable there, you can call it myImmutable. And then you can change 1 or 2 of the lines. So for instance, in tuple constructor, it's got defaults equals false. If you want to make a myImmutable and have defaults equals true, you can just go and create that yourself. And then you can have that behavior spread throughout your code base, and you've got that power in your hands. So that's a great feature to have. And if you've ever tried to use immutable with dependency injection, a lot of dependency injection frameworks really only wanted to have a single constructor there. That's the way they work, is they make that assumption and they find that constructor during the injection process. You can now actually get immutables, and just by mixing in canonical, property options, and immutable base, you get something which is very close to an immutable, not quite, but it mixes. By using canonical, it's actually going to grab 3 of the things that were in my previous immutable, and it'll so you can mix and match that collection in with these other 3, and so you can sort of arbitrarily mix and match collections and collections of collections, or whatever you need. And this is a nice way to get an immutable. It's an effectively immutable that's going to be friendly towards dependency injection. Very powerful. Okay, I did say I was going to talk about what the second last line in this thing here, prefer explicit merged. I did have a slide on that, but I've hidden it to try to get through all the material that we've got to cover today. So I'll just briefly mention, there's actually a few different ways to, when you're creating these annotation collections, what happens if I use immutable and I also put my own toString with different annotation attributes. So here's immutable. What if I go add immutable and I also got at toString, and I for whatever reason I want to turn caching off? So you can see by default, when you on an immutable, it's not supposed to change. But maybe I've got a internal field that's some sort of counter or something. I don't know why you'd ever do something in an immutable that was changing. If you wanted to turn caching off, you just put the @toString cache equals false there. What this second last line there, the prefer explicit merged, it tells you what's going to take precedence if you get both of those things. So here, if you go and put toString by itself, that's going to be preferred to whatever's in the canonical collection. That's what that last line was. What else has been changing? Immutable now recognizes all the JSR 310 date classes, so the java.time package. So if you've gotten rid of Java util date and calendars and friends from your code base, and you're using all the new java.time classes, you can happily use those in all your immutables, and everything will be happy. Okay, because we've made everything fine-grained, you can actually dive in and tweak things with a lot more ease. So when you used to have collection types in your immutable classes, we would go and provide you with an immutable version as per what the JDK would give you when you call its unmodifiable utility classes in the collections class on those lists. So that way it would ensure that those classes were never changed. Now, if you're not a particular fan of the unmodifiable feature that's in the JDK collection classes, and you reuse Guava immutable capabilities throughout the rest of your code base, you might prefer that was used instead. So you can actually go and write a property handler. There's a special handler class that deals with making things immutable. And I've got a little example of using Guava as the immutable property handler. I haven't shown you the code for that, but I've got that available if anyone's interested and wants to have a look. It's not very many lines of code, and it gives you full control. And that's part of using the fine-grained approach of splitting immutable up allows you to sort of weave in and do very microsurgery, making little tweaks like this that allow you to customize things in a very nice way. If you're using immutable in conjunction with Java 8's optional classes, you can now use those happily, and as long as the thing that it's the optional of, so here I've got optional string, that'll be fine. Because string is an immutable class, that'll be allowed, and everything will be happy there. If I was to use something which wasn't immutable, so if I did an optional of some non-immutable class, then I'd get an error. So all the same classes that would be, if I used a base type that wasn't allowed inside immutable, and an optional of that base type would also not be allowed. Okay. Oh yeah, there we go. Java 8.3 point is a mutable class. So there's the warning message you'd get if you tried to use that. One of the things that we've been adding to Groovy is to allow you to do compile static and so on in a lot of places. That allows you to pick up a lot of the kind of errors that that Java would normally pick up for you. And one of the holes in that strategy was if you were using annotation attributes, throughout your code, all those checks would take place, but inside the annotation attributes, if you made similar kind of typos or whatever, they wouldn't get picked up. So for instance, in this example here, I've got excludes equals first, but in fact, there's no first property in my little class cyclist here. Well, cyclist is a good name for this class. My cycling buddies are meeting. They met like 3 minutes ago, just down the road to go out on, it's Saturday morning here in Australia, and they've just headed off to go for a little cycle. It's just on daybreak here. So that's obviously what this class was created to represent. Now, what's going to happen if you try to compile this up now is during the compilation process, it'll say first does not exist, and you'll have to go and correct that and obviously make it first name, which is what was probably intended. Okay, there's a couple of slides. So tuple constructor has got a few new features. One of the things that to understand what it provides, you need to understand how tuple constructor works. So here we've got two classes, a class flight and a class cruise, and they both have a from and a to properties, from a city, from a port, and a date leaving. On the first one, I'm going to have defaults equals false, and on the second one, I'm going to have defaults equals true. Okay, so when during compilation, what's going to happen is effectively for the first one with defaults equals false, it's just going to provide the constructor there, and it's going to fill in all the properties that it finds. So you'll see string from city, string to city, date leaving, and so on. For the second one, with defaults equals true, because I haven't gone and specified initializers for those initial values for any of those properties, it's going to create default versions for them, but setting them to null. I could have actually put some properties in there and you'd see those property values instead of the null. Not really needed for the example that I'm going to show you. What happens next? Normal Groovy compilation kicks in. And if you were to write those constructors by hand yourself, what would happen if you put those initializers in place? Groovy would automatically provide multiple constructors for you in the second case. Same would apply for methods. Okay, so obviously Groovy's compiling into the same bytecode as Java. In Java, you'd need to write all 4 of these out by hand. Groovy's just doing, saving you the work of having to do all of that. So the Groovy compiler would normally do that sort of thing underneath the covers. So for the first case, you'll just get a single constructor with all 3 parameters. For the second case, you'll get the 4 constructors, one of them having all the parameters, and then additional versions having 1 less parameter each. And what the 3 parameter version will do is it'll call the 2 parameter version, passing in the date as null, and then the 2 parameter version will call the 1 parameter version, passing in the last string, the 2 port as null, then and so on and so forth. So that will automatically happen underneath the covers for you. Okay, so this gets this is just a bit of an explanation on why having that defaults capability is really good for dependency injection. For dependency injection, you'll typically want the first case. For flexibility, doing stuff by hand where you're not using dependency injection, the second case is a good choice. So, but now you've got both of those options there. What else has happened with tuple constructor? There's pre and post closures. So one of the again, one of the things that things like immutable or even tuple constructor by itself, people didn't like was they're getting this pre-canned constructor made for them, which was great, but they just wanted to have one extra little check in there, some sort of validation logic or whatever it might be. And because tuple constructor or immutable didn't provide that for you, you had to go write the whole stuff by hand, the whole constructor by hand, which was some people were felt wasn't ideal. So now with those pre and post closures, you'll get the canned constructor, and in addition, the code inside the supplied closure there will be added at the front or the end of the constructor. It's a very, very powerful feature. Okay, this is another useful feature. So there's a visibility options annotation attribute, annotation, which allows you to tweak what visibility is given to any, it could be a created constructor in this case, or it could be other things. So the visibility options can be used in combination with a number of the annotations. In this particular case, you'll get a make person tuple constructor created for you that will be in fact private. Okay, so you can, using Groovy's dynamic capabilities, you can actually, well, actually, we're just using the static make person class. So we've got a factory method called make person that we've created, and it's calling the private constructor. But because we've used tuple constructor there, we'll automatically get that constructor. It'll just be private. So I can go and look up all the public constructors and check that there's none. So that's now the only way to create a person class is through the make person factory method, but I didn't have to write the code for that. So that's great. So I've mentioned it before, but there's now a map constructor. And you might wonder, why do we need the map constructor? Because doesn't Groovy do some sort of automatic map sort of style notation that automatically is handled? And yes, in fact, if I left the map constructor out, I could use the exact same notation, and Groovy would actually create a NOAA. It would create the kind of constructor we saw for tuple constructor that had all, remember we saw one that had 4 different versions, had 4, 3, 2, and 1. It would create a thing like the bottom code there with 4, and you can see that the one of the 4 is a NOAA constructor. So in fact, if I'm using a class conference and I use I don't have map constructor, and I use the named arg notation, so I've got name, city, and start as my properties, then it'll in fact call the noarg constructor, and then it'll call as separate. It's all hidden from you, so you don't really need to know this is what's happening. It'll then call set name, set city, set start, and so on. The nice thing about the map constructor is it would allow you to have final fields. So with Groovy's normal named argument support, because I'm calling the noarg constructor, that would set everything to null, assuming I didn't have any default initial values. And then I'd go and try to set name, set city, and set start, and so on. That wouldn't work in combination with final. Map constructor allows you to get the same behavior with the named arguments, but also allow you to do final if you wanted. Excuse me. Groovy's got a number of great capabilities for doing dynamic creation of dummy objects of various kinds. So I won't go through all of these examples there, but if you want to create a dummy iterator, and perhaps you're doing some sort of test on a test class that's going to test all the properties of iterators, and you wanted to create some sort of dummy iterator, you could go and create yourself your own custom iterator class that extends iterator, start filling in all the properties. What Groovy would let you do would be to, let's have a map with a hasNext method, which returns false. And that can be an iterator simply by going as iterator. And it'll create using Groovy, normal Java proxy approach. It'll create a class for you that actually has false as the code. The closure there is the code that'll be inside the hasNext method. And it'll create that for you automatically. So that's really, really good when you're using Groovy in its dynamic mode. What would you do if you preferred to have sort of the more static approach? Well, that's where auto implement comes in. So you've now got a dual on both camps, whichever one you want to, whichever style is appropriate for your particular problem. You can now do that. So if I do auto implement, it'll basically flesh out that class for me, and it'll fill in all the methods in if there's any. It'll look through any abstract classes, look through any inherited classes, and any implemented interfaces, and any abstract methods that it finds that you haven't implemented. So you'd be free to implement some of them if you wanted. Any that you don't implement, it'll basically go and fill in with empty implementations. Now, what does empty mean? It'll be, if it's a void method, it will actually just be an empty method that gets created. If it's got a return type, it'll just return null, or for the primitive types, sort of 0 or false or whatever's appropriate. Okay, that's just, you can actually go and check that it's got the methods there and so on. I'm just proving that the class that gets created is behaving as you'd expect. Now, that was an example that showed the code being supplied as some sort of default empty version. As an alternative, you can make all of your empty implementations throw an exception. You can have an exception with a particular message, or you can actually supply the code yourself as well. So there's a little bit of flexibility in specifying those. Another feature that some people really like is the ability to have finals everywhere. And rather than cluttering up your code with lots of the final keyword everywhere, if you put auto final on a class, it'll automatically put final in actually that's probably a bug in one of the slides, but I won't bother going into that. Okay, there's it'll put, if you put auto final on a class, it'll put final on all the method parameters and constructor parameters right throughout the class. If you put it on a single method, it'll just fill out that particular method. So in fact, there shouldn't be a final in the feed all method there. I'm not sure how that got in, but anyhow. Just a little tweak to the delegate annotation. You can now, typically you would put that on a property. So you might have a string full name property and you delegate to that. Okay, you can now put it on a getter for a property. So that's a nice feature. There's another feature called named variant. If you remember, the named properties stuff I was talking about before, the way Groovy can support named properties for constructors, it can be, you can have the no-arg constructor and then setters. For methods, what Groovy will do is it'll support a map-based version of the method. And again, you might not normally see this a lot of the time. It'll just happen underneath the covers for you. But what named variant will do is it'll create a mapped version of the constructor and it'll call through to the version that you annotate with named variant. So what's going to happen here, because I've got a constructor here that's private, and I've got it's strongly typed, and I've got named param and so on, as well as named variant. You don't actually need all of that. I probably won't go through all the details of the various options here. This is going to provide a map-based constructor for you. Because I've got the visibility options set there, it'll be a public constructor, and it'll just, the one that gets generated is just going to call through to this one. Okay, so what you'll do is you'll have a color constructor that you can use the name arguments with, but one of the problems with that map-based constructor is you lose strong typing. So a map has just got a key of objects. Well, it's got it'll have string keys, which are the property names, and then just objects as the values. So if I went and wrote a mapped-based constructor by hand here, then I wouldn't be able to get the strong typing very easily, or I'd have to make my code very convoluted in order to force that sort of thing to be happening. What I can do with this one is, because all of my parameters here are now strongly typed, all the code that I write inside here will be can be type checked. I can put type checked or compiled static annotations on this, and everything will be type checked, but I can still have the map-based constructor here, and named variant will give me that. Now, the named param in combination, I won't bother going into the details. There's a lot of times when you won't even need to put the name parameter in. There's a default behavior where it just assumes all the properties are going to be named parameters. What you're going to see is over time we're going to add this sort of feature into Groovy underneath the covers. So you won't necessarily see all this, but there'll be a lot more places where type checking is going to be occurring where it isn't occurring at the moment because of the map-based approach that's taken. So that's what it's going to look like. So the named variant annotation is actually quite powerful. You can actually have named parameters, which are parameters that get passed through. You can also have named delegates. Named delegates, it's as if I've got a color or an animal, it's as if I've filled in all of the properties of color or all the properties of animals into the definition as well. So if in this particular case, you'll see that you're passing through named args.r, named args.g, and named args.b as color. So that'll get passed through. So all your strong typing will be there, and it'll get passed through to the next layer down. Okay, the next feature I want to talk about is macros. So macros are the ability to, so what I've shown you from nearly the whole of the talk so far is a whole lot of AST transforms, and that's one of Groovy's strengths. Up till now, if you wanted to create one of those transforms, you kind of needed to know about all of the internal details of the compiler. So there's a lot of data types that the compiler uses to represent your program. So it has method nodes and class nodes and if statements and expressions and switch statements and all sorts of things that you would need to know all the different types for. What macros is trying to do is put the hands of AST transforms into people that don't necessarily know all the low-level compiler details, but know how to do Groovy. So if you think of Excel and VBA macros or something, Excel was a wonderful thing for if you're writing all your spreadsheets, but if you wanted to extend its capabilities, you'd have to go and program in C code or whatever Excel was written in. But macros allowed you to write really simple things that someone who's typically feeding in stuff into a spreadsheet might be able to do. Well, that's the idea of macros. So the idea in the top part of the slide, this is the, if I'm trying to create some sort of AST transform that inserted a new date into the class, I'd need to know how to get to the compiler's representation of the date class. I'd need to create a new constructor call expression. I'd need to pass it in an empty arguments list and so on. Now with macros, you can just write exactly what you'd write if you're writing Groovy code yourself. It's quite a powerful thing, and you can actually mix and match. So the first two lines are the kind of stuff I would write old school. So I'm using the data types that the compiler knows about. So there's a variable expression data type. I'm creating a new instance of that with it takes a parameter, which is the name of the variable. So I'm creating one for X and one for Y. So I've gone and done that old school. When I'm using a macro, I can actually now mix and match between things that exist or that already exist, that I've already created, as well as stuff that I want it to go and auto convert for me. So that now I can go do math.square root, and if I go $v curly braces, inside the $v curly brace part, it won't try to automatically convert back for me. So in this example here, whoop, oh, that was not the right thing to do. In this example here, the return new date, it automatically converts it back to what you see on the top box on that slide. When you see a $v curly braces, it'll convert everything on the outside. So it's actually quite a bit of code. It's calling a math square root function. It's got some exponentiation in there. It's then calling the int value method on the result and so on. So there's quite a few lines there. It'll go auto convert everything, but when it gets to the $v parts, it just inserts. It stops trying to convert everything inside there. It'll just insert the stuff that I've pre-created. So that's good. I can actually mix and match between the two worlds. And the final example is just showing that same example again. But what I can do is the compiler actually has multiple phases. So I can actually stop it at a particular phase, and there's a little boolean there. I can make it return either an expression or a statement by however I've got that particular flag set. So that's a very powerful feature. There is a macro class as well as, so macro that we saw just here, that's going to return an expression or a statement depending on the optional Boolean parameter that was there. If I actually want a whole class returned, then I can use a macro class. Okay, so that's sort of like a placeholder in the code. If you ever see new macro class, then everything that's inside the definition there will be what gets converted back and put into that class. Okay, and that's showing you the whole code there for creating a statistics annotation there. So it's going to return the method count and return the field count. Okay, it's a very powerful feature. There's an AST matching capability as well. So here's a little piece of code that you might wonder what it's doing. So I've got a reference expression, and I'm using a macro to create that reference expression, and it's just the expression 1 + 1. So it's just going to be a constant 1, another constant 1, and then it's going to be calling the plus method for those two constants. And I've just saved that away as a reference. Then I've got an AST matcher, which looks at any expression that gets given and checks whether or not it equals the one it saw before, which is the reference one. And if it ever finds the reference one, it'll replace it with a different expression, which is just the macro 2, which will just be a constant 2. So it's a fairly trivial one, but what this is going to do, this is creating myself a transformer that I can apply during compilation time that will optimize my code during compilation, and anywhere where it finds 1 + 1, it'll just automatically replace it with 2. And it does that at compilation time rather than having to do that thing at runtime. And you can actually have placeholders there. So instead of having 1 and 1, I can make it match anything, and then do the calculation at runtime and supply that. Now, if you want to see, so what macros enables is allows you to write very, very powerful, in order to support the macro, I should take it one step back. In order to support this macro function, when Groovy is compiling your code, it sees this method macro and it knows that that's been defined as a special macro method. In order to support that, the Groovy compiler is looking for particular method names that it knows are related to macros. So macro is obviously one that's being used for all these macros, but we've opened that up and you can actually define your own method names there. And that's called macro methods. And there's a whole lot of really powerful ones that have already been created. So there's one called match. So if you put match num, then you can go when string, then factorial list, when 0, 1, then 1, when 2, then 2, or else num times fact num minus 1. So this, if you're got envy over pattern matching, this is a good alternative to have a look at. And again, that's all done as a macro method. If you like Spock, but you'd like that kind of capability in your production code rather than just in your tests, there's a do with data macro method. And that lets you put this sort of thing inside your prod code. And there's more examples on those websites. So there's a couple of there's some features that I haven't really talked about, and I want to get onto the Parrot parser, so I won't spend very long on these, but I'll mention them as we walk past them. There's repeated annotations is something that you can have in Java that allows you to have an annotation array capability that's now supported. Some examples of that. Method name parameters. When a Java class is compiled, it kind of loses the method parameter names as in Groovy. Both Java's got a support for a minus parameters annotation attribute, which remembers those names, and Groovy supports that as well now. Annotations in more places. So if you want to have, just looking at the last line, if you want to have a non-null arrays of non-empty read-only string items, then you can put annotations in all different places. So some of that's turned on in 2.5, and more is coming in the Parrot parser. Groovy shell gains the ability to use grab, so that's useful. If you've used the with operator in Groovy, there's now a tap version that returns the original object. So if you're wanting to do with, but have the result of the expression be the thing that you fed back into it, so you can sort of do like a piping operation if you do that, then tap is a good one to have a look at. So yeah. CLI Builder now supports an annotation flavor as well as the normal very compact dynamic behavior that it's had in the past. There's improvements in the Jaxby area, improvements to the JSON serializer. You can customize it now. Whole bunch of miscellaneous features. What I want to talk about next is the Parrot parser. So you might wonder where the Parrot parser got its name. There was very early work done on creating a new parser. We've been using Antler 2 as the parser for a long time in Groovy's history, and it's gotten to a point where making any changes in that old parser, the parser is no longer supported. Making changes has become difficult. So we've been wanting to move to a newer version of Antler for a long time. We created a Google Summer of Code project, and to give someone a high-level goal of what this new parser was supposed to be, what we said was, you're going to feed Groovy code into your new parser, and what it should spit out should be the exact same AST, all this AST stuff that we saw mentioned earlier on. What your parser should spit out should parrot exactly what the current parser spits out. And that's where it got its name, and that's how it started. And Daniel's son has been doing a lot of wonderful work, taking it a lot further since the early days of that Google Summer of Code project. So let's have a look at some of the features it has. You can now do a do while loop. The classic for loop has been enhanced. It supports extra commas now. So we've supported the classic for loop for a while, but not with the commas. So you can actually have multiple terms in the three parts to the normal classic for loop. You can put those commas in now. You can actually have multi-assignments in your loops. So Groovy supports multi-assignments for a while, but just not inside the loops previously. You can now have them there as well. Java style array initialization is now supported for a couple of particular styles. That style there, and there's another style as well that's supported as well now. There's some new operators. So if you remember, what Groovy decided to do was, rather than use dot equals as the notation for business equality, use the double equals, right? That's what most people would expect to see. If you then wanted to have reference equality, then Groovy provided the is operator to do that. The is operator is still there, but you can now do the triple equals operator. So it means they're pointing to the same object, not just equal as in equal business value. There's a not instance of and a not in. If you've ever had to put brackets around an instance of and put not at the front and so on, it can very quickly become difficult as to which ways that flipped and so on. When you're trying to read it, this reads much better, makes your code a lot clearer, gets rid of unneeded brackets. There's an Elvis assignment operator. So if you remember, the Elvis operator, question mark colon, says that if the thing on the left is null, use the thing on the right, otherwise you just use the thing on the left. In the case of an operator, so name equals name, question colon hydrogen, it's you're still repeating name twice there, so you can now just do the question mark equals, and that'll do all of that in one go. We've always had safe navigation with the question mark dot operator in Groovy. Now there's safe indexing. So if you do a question mark and then have an index operator, if the array itself is null, then you'll just get null back. Okay. Now there's a whole lot of things that some Java syntax that there's usually better idiomatic ways in Groovy to represent some of the nice operators that Groovy provides. Means that you don't ever need to use some of the things try with resources in Groovy, but a lot of people were copying Java code over and wanted to all that to still work, so that's supported. So you can use the Java style, so try, and then you specify your resources in brackets there. They'll automatically be closed. And there's slight Groovy friendliness there as well. So you can get rid of the type specs if you're in dynamic code at least. Just remember that Groovy's IO and resource extension methods, the default Groovy methods, often mean you don't need to use that style at all, but there you go. Nested blocks, very rare that you need to use them, but if you just have an opening curly brace and a closed curling brace, you'll have a new context. You can define things in that context and they won't exist outside that context. Lambdas. So one of the nice things that Groovy's done previously is that with SAM coercion, if you've used a closure, it would automatically get mapped underneath the covers onto any Java methods that were expecting lambdas. So that was all good, but the notation was obviously different. Now you can use the same notation that you would use in Java. You can use that directly in your Groovy code. Okay, so there's various flavors there. So if you put compile static, you'll get a native Lambda. There's a native Lambda implementation that in the current Groovy 3 means you'll get a slightly different version. That might be optimized further yet, but it's certainly a much more optimized version of than having a full closure there. Okay, all the different shapes are supported. So you can have multiple parameters. If you have multiple parameters, you need to put the round braces around your parameters. Okay, if you've got just a simple expression on the right-hand side, you can drop the curly braces. The parameter types are optional, and the explicit return is optional. So some nice features there. Okay, some value add over and above what Java gives you. The last example on the right-hand side there, there's a default parameters been given. Method references, they're supported. So for class and instance variations, static and instance examples, constructors, multi-dimensional arrays, all sorts of examples that you can do in Java. They're all supported in Groovy as well. And they work on your own classes as well, all those different versions. Default methods in implementation, in interfaces, they're currently implemented as traits. So the implementation is a bit different to what Java would be doing, but it results in the same behavior in most cases. Again, we might look at tweaking that down the track, but that's what we've got at the moment. The final thing that I'm going to mention is GroovyDoc. So there's a few different things that are supported. So you can get GroovyDoc being available as metadata that an AST transform would be able to see. So there's support for that. And there's also support for embedding the GroovyDoc documentation in your class files. So instead of, in the future, having to download a source, a doc jar, as well as the code, so your IDE would need both jars in order to give you help and so on, that might be available automatically inside the class files themselves. So that's just something that we might extra support for down the track. Okay, well, hopefully that's given you a bit of a view of what's happening in the 2.5 space, which, as I said, is very close to being released now, and what's coming further down the track. We're very keen for, we've got a very wonderful, supportive community, lots of people who contribute to Groovy. Very keen for your feedback, very keen for any help, and we look forward to a long journey of Groovy going forward.